Today we're going to look at 2.6, drawing scatter plots and best fitting lines. So we're going to start with vocab since some of this is brand new. And let's look at a scatter plot. So a scatter plot is a graph of a set of data pairs. X, y. Right? A positive correlation is when if y tends to increase as x increases. So this looks like positive slope. Negative correlation, if y tends to decrease as x increases. So this looks like negative slope. Right? And then a correlation coefficient is the letter R, and it's a value between -1 and +1. It measures how well a line fits a set of data. Fits a set of data. The closer it is to -1 or +1, the more linear the line is. So if it had an R equals -1, then the line would be, the dots would be all lined up in a negative pattern. If R is equal to +1, the dots would be all lined up like a positive slope. And then 0 would just be a giant scattering all over the place with no pattern. A best fitting line, or sometimes it's called the line of best fit. Our book chooses to call it the best fitting line. It also can be called the least squares regression line. So the best fitting line is the line that lies as close as possible to all the data points. And again, you've probably seen this before, but this is the least covered material that we continue to cover over and over, and I just wanted to make sure that you knew what we were starting with here. Alright, so for this is an example of two separate graphs, and for each scatter plot we're going to describe the correlation shown and tell whether the correlation coefficient is closest to -1, -0.5, 0.5, or 1. So we're going to look at this first graph, and we can see that these are tending to go downhill. You always read a graph from left to right, and this is going down. So this would have a negative correlation. So how close is it? If they were all in line, which they're not all in line because they're scattered out, it would be -1. If it was -5, they would be more scattered. So this is close to -1. It's probably more like -0.8. Right? The second one, this is positive. So again, if we read the graph from left to right and kind of look and see what's going on, we can see that they tend to have an uphill motion. So this is positive. The points are not as close together as they were in the first example. See that they're more spread out. So this is not 1. 1 would look like if they were all just in line, one right after another. So it's not 1. 0.5 would look like if they were kind of scattered around. We do kind of have something like that. So this is more like 0.5. Positive, because if you think of them kind of like a bunch of bees going in the same direction, they seem to all be going uphill. The steps that we need for approximating a best fitting line, or a line of best fit, is we're going to draw a scatter plot of the data. Then we're going to sketch the line that appears to follow most closely the trend given by the data points. There should be as many points above the line as below it. So we're just basically like shooting an arrow through the points, and we're trying to shoot so that we have an equal number above and below. Step 3 is choose 2 points on the line and estimate the coordinates of each point. And it has to be on the line, that's key. And then the 4th one is write an equation. So luckily we just went over how to write an equation of a line that passes through 2 points. Alright, so let's look at this example here. So the table below gives the number of people, Y, who attended each of the first 7 football games, X, of the season. And we're going to approximate the best fitting line for the data. So we have the data. First thing we would do is draw a graph. So I have done that for you. And then I went ahead and I sketched the line of best fit. So you could see that I tried to make it so that there was an equal number above and below, and that the line went through the points. I didn't hit every single point, because that would be impossible unless they were all in line, one right after another one. Okay, so hopefully that makes sense to you. This little break just means that we kind of skip some numbers. So instead of doing 1, 2, 3 all the way to 650, we just started our pattern at 650. You may have seen that in science class. Alright, so we're going to choose 2 points. So we're going to look, and we can choose any of these 2 points that lie on the line. So we want to first start with the ones at 1. So we're going to approximate what this point is on the line. So that looks like it's the point 1 and then 725. And then where 2 is. So 2, we can't pick the point this time because the point is above the line. So we're going to approximate where it intersects that corner of the graph. So it looks like it intersects at 750. Notice the point is about 760. Maybe 770, so we did not pick the point. We picked where 2, the line at 2, intersects with the graph. Alright, so we picked our 2 points. So now we're going to write an equation of a line based on the 2 points we just picked. Remember that our points were 1, 725, and 2, 750. So all we're going to do is use the slope formula that we used yesterday. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's 25 over 1, which is just 25. Now we're just going to use one of the points. They say to use x1 and x1 and y1, so I guess we'll do that. So y minus, this would be 725 equals 25 times x minus 1. And then we're going to simplify. So I'm going to do that over here. Y minus 725 equals 25x minus 25. So I'm going to add 725 to both sides. And I get y equals 25x minus, plus 700. Okay, and we're going to have approximation of the line, best fitting line is, and that's what the y equals 25x plus 700 is. Now tomorrow in class we're actually going to do an activity that requires us to go through these steps. So make sure that you understand these steps, and if you can do that, you'll be a superstar at our activity.